everybody, and welcome back. In this video, we're going to analyze quadratic equations a little bit deeper than we did last time. So last time we proved the quadratic formula. So now let's go ahead and write up that the solutions to a quadratic equation in standard form. They're given by this, right? So this is what the quadratic formula tells us. Now let's zone in on what I'm about to underline in red. B squared minus 4ac. This has a name, and it is called the discriminant. Discriminant. This is the discriminant of a quadratic equation, or a quadratic expression, and it's given by b squared minus 4ac. Now, how we're going to study our quadratics is going to be based on the discriminant. So here's what I mean. Let's just say that the discriminant b squared minus 4ac were negative. So it's less than 0. Then, so this is like case 1. Then we have no real solutions. Okay, now let's look at another case. Let's suppose b squared minus 4ac were equal to 0. Then we would have one real solution. And the third case, if b squared minus 4ac were greater than 0, then we have two real solutions. Okay, now let's zoom out and let's just make sure we understand all of this. So in case 1, we've got no real solutions, because then we would be taking the square root, we'd be taking the square root like this, be taking the square root of a negative number, right? And remember from before, we cannot take the square roots of negative numbers without leaving the real numbers. So in other words, square roots of negative numbers are imaginary, they're not real. Next, you have the case 2, where b squared minus 4ac equals 0. In that case, the solution would be x equals negative b plus or minus the square root of 0 over 2a. But the square root of 0 is just 0. So we're adding and subtracting. We're doing plus or minus 0. And that's why we only have one real solution, because adding and subtracting 0 has the same exact effect. So we've covered the first case, the second case, and the last case, we get two real solutions because you're taking the square root of something positive. So that gives you two, that gives you a specific value, right? If you take the square root of a positive number, you get back a positive number. But then when you go through the formula, remember you need to take it and add and subtract it from minus b and then divide by 2a. So really you get two real solutions from that. So these are the three cases that you can fall into when you're looking at a quadratic. And I think it's more enlightening to see what these cases look like with a picture for each of them. So why don't I off to the right now, let's take, in blue, let's just draw the graph for case 1. Not the graph, a graph. So let's draw a quadratic equation that has no real solutions. Well, how about this guy? This is the graph of a quadratic that has no real solutions because it never intercepts the y-axis. It stays above it always. It has this minimum right here. So this would be like case 1. Case 2, say you got your x and your y-axis, and let's just say, so now we've got one real solution, so let's just say it looks like this. Notice it only crosses the x-axis once, right here. So that's why there's one real solution, because it's tangent to the x-axis. This parabola is tangent to it, so it's just touching it. And lastly, we've got case 3, and that could look something like this. Notice we've got 1, 2 points of intersection of the quadratic with the x-axis that corresponds to our 2 real solutions. So now there's really only one more thing left to say about the discriminant business, at least for this class. There's plenty more you could learn about this topic. If you're interested, reach out to me. Uh, I guess there's just one more thing to say, and that's that let's consider, let's just say that b squared minus 4ac is a perfect square. And maybe just with an example, let's say b squared minus 4ac were equal to 9 or something like that. It doesn't have to be 9. It could be any perfect square. Then the solutions to the quadratic equation are rational. And that's because if you take the square root of a perfect square, remember in the formula above, pan up, we're taking the square root of b squared minus 4ac. So if the square root is being taken for something that is a perfect square, you're going to get back an integer, or you're going to get back, say, I guess if it were a fraction squared, you would get back a rational number. But anyway, the point is that you're adding and subtracting rational things and dividing by rational things in this formula at that point. So therefore, the solutions to that quadratic equation would be rational in that case. So that's about all I have to say about discriminants, and at least for this video. But all I have to say for discriminants, and these are the 3 cases that they can fall into with their corresponding uh, pictures, their graphs with those quadratics graphed. And notice the number of intersection points is ultimately what characterizes it, and we can analyze that straightforwardly by looking at what's called the discriminant. So maybe in another video I'll look at an example and flesh this out in more detail with an example that way. So anyway, we'll see you all in the next video. I hope you enjoyed this one, and take care and have a great day.